Okay, this is an interesting problem. So, problem is given here. Two particles of mass m, this is mass m, two particles are tied at the ends of a light string, this is light string of length 2a. The whole system is kept on a frictionless a horizontal surface. This system is kept in a horizontal surface. Okay. With a string held tight so that each mass is at a distance a from the center P. From center, distance of each mass is a. So total distance between two particles is 2a. Now the midpoint of the string is pulled vertically. So midpoint means at this point. Okay, so this point P is pulled vertically upwards with a small but constant force F. Okay, this is constant force. This just pulled up vertically upward. As a result, the particles moves towards each other on the surface. So if I pulled at this point with a force F, these two particles are moves towards each other, okay, on the surface, and the magnitude of acceleration when the separation between them is 2x. At that condition, when the two particles move towards each other on the surface, I have to find out the magnitude of acceleration when the separation between them is 2x. So now the picture will be in this way. So this is m mass and this is m mass, and force is this. Thus this is the constant force F. Okay. When we apply, when we midpoint the string pulled vertically upwards, a small but constant force. Okay, at this point with small but constant force we apply a force at that point. Okay, so the system is now become this. Okay, so tension at this string will be T. This is upward, and at this string will be T. Okay, and okay, so if it is a this is a small problem. Okay, and if we draw a perpendicular at this point, we draw a perpendicular, and if it is theta, this will be theta, this angle also make perpendicular theta. Okay, so and the component of T, tension T, will be this component and this. If this is theta, this will be theta. Okay, so this vertical component will be T cos theta and horizontal component will be T sin theta. Similarly in this case, so in this case horizontal component T sin theta, vertical component T cos theta. Okay, and we see that the horizontal component, this T sin theta and T sin theta, magnitude same and direction just opposite, they cancel each other. Okay, so only vertical component contribute here. So at this point net force will be 0. So if we take this point is equal to O at this point, so we can write that F is equal to 2t cos theta. Okay, so so just at this point will be 2t, at that point 2t cos theta. Okay, now again for a particular mass, this is m, this is mg, gravitational force mg, and this is theta, so tension at this point T, and again this is theta means this will be theta, So t cos theta is equal to mg. Okay, and this component is t sin theta. This t sin theta, and again there is another string which t sin theta cancel each other. Okay, so as t cos theta is equal to mg and f is equal to 2 cos theta. Okay, so we can replace this t cos theta is equal to mg. Okay, so f is equal to, you can write from this equation, two equation, as f is equal to 2t cos theta and t cos theta is equal to mg. So we can write f is equal to 2mg. This is an equation. Okay, then what have to done? So question is, as a result, when pulled at this point P with a force F vertically upward, particles moves towards each other. Okay, this particle comes together, move towards each other. The magnitude of acceleration I have to find out. Okay, when the separation between them is 2x. Okay, when this situation is happening, this situation, this is f, this is separation between them is 2x. So from center this distance is vertical distance x, and this particle distance x. This is theta, this is theta, this is t. Just again I am drawing this picture. This is t. Okay, so question is asking that they move toward each other with a magnitude force and magnitude of acceleration you have to find out. So at that point t cos theta component just balancing their gravitational force. Okay, so at that direction component of t is equal to t sin theta. Okay, so this t sin theta we can write down with this t sin theta, this particle moves towards each other and this particle moves towards each other. Okay, t cos theta component is just balancing the gravitational force. Okay, and this with this t sin theta component of this tension t sin theta, this particle moves towards this particle with acceleration f. Okay, so we can write that t sin theta is equal to mf. F is the acceleration. Okay, so I have to find out the f. So f is equal to t sin theta by m. Okay, so I have to see the options in which form I have to write this. So x a, in this form I have to write this x and a. Okay, so f is equal to t sin theta by m, and t is equal to, we can write that this t is equal to we have two formula, f is equal to 2 cos theta and t cos theta is equal to mg. So we can write this t is equal to f by 2 cos theta, or this t is equal to mg by cos theta, any formula we have to write down. So this t is equal to, firstly I am written this t is equal to mg by cos theta. Okay, t is equal to mg by cos theta. So mg by cos theta, just I substitute this value by into sin theta. Okay, and denominator also have m present, so this m cancel out. Okay, so this f, acceleration f, is equal to g tan theta. Okay, and one thing, as answer is in this form, f m a x, no g present in answer options. So f is equal to 2mg, so g is equal to f by 2m. Okay, so g is equal to, just substitute this f by 2m into tan theta. Okay, and tan theta is equal to perpendicular by base. So from this right angle triangle we can write down this tan theta is equal to x, this is perpendicular, and base is this. From Pythagoras theorem this is a. Okay, why this is a? Because as this distance is when we pulled out with a force F at the point P, this distance should be a, okay. Just I am pulling out at the point A, P with a force F upward, so this distance obviously becomes remains same, okay. Okay, so T sin theta is equal to, this is perpendicular by base, and Pythagoras formula, this is a square is equal to x square plus, if we write it as y square, this is y, base is y, so from this right angle triangle s square is equal to x square by y square, so y square is equal to root over s square minus x square, and just turn down this root over s square minus x square from this Pythagoras right angle triangle formula, okay. Y is equal to root over s square minus x square, and substitute this, and tan theta is equal to x by root over s square minus x square, just putting this in this equation, f by m x by s square minus x square, okay. So I think f by 2m, which option is correct? So f by 2m, so x by root over s square minus x square, this is a by this, so this option is B is correct, okay. This is an interesting problem, so I have to use all these component of force balancing at this point. F is equal to 2t cos theta, from at this point total net force is 0, and this t sin theta components cancel out each other, and again this t cos theta is equal to mg. This t cos theta compensate the gravitational force or balance the gravitational force, okay, and these two particles move each other with acceleration f, okay. So this t sin theta component helps to accelerate these particles to move each other, okay. This is t sin theta component is equal to mf, and t cos theta is equal to mg. Let's substitute these terms, so I have getting this result, okay. This is an interesting problem from Jee Advanced, okay.